All right, Grenier. Oh, there is no Ava today. Anders, you're the emergency pinch hitter here. Grenier, sine of pi over 6. Uh-oh. Pi over 6, shallow angle. Sine is the y-coordinate. So you want to reconsider that answer? It is a half. It is a half. Sine goes with y. Pi over 6 is shallow. So the short side is 1/2. Tyler, the cosine of 2 pi over 3?
Negative 1/2.
Good. Negative 1/2. 2 pi over 3 would be a steep angle, second quadrant. Cosine is x. So there's negative 1/2. Anders, you got a little bit of a hard one here. Tangent of 5 pi over 6.
That would be good for me. I got negative square root of 3. Is that wrong? Over 3?
Over 3. Yes. So I know you had the negative right because you guys were arguing about where 5 pi over 6 is. And you were right that it's not to pi yet, so it's definitely in the second quadrant, which means it needs to be negative. And then the tangent 3 trick, so there's two ways to do tangents. I saw a few of you doing the sine over cosine, so 1/2 over root 3 over 2, which eventually gets you root 3 over 3. There is nothing wrong with doing that. It doesn't take long. It's fine. It's less to memorize. I've done them enough that I remember the tangent 3 trick is if the angle has a 6 in it, then the answer has 2 3s in it. And if the angle only has 1 3 in it, then the answer has 1 3 in it. So if you want to memorize tangents, that's how you do it. If you don't want to memorize tangents, because it's like, we don't do this often enough for me to memorize this now, I'm just going to do y over x, that's also fine. So either way to get there. Alan, there was a lot of people that missed cosecant of pi. What did you get for cosecant of pi? I wasn't going to call you out for that. But yes, undefined. Because most of you had this. 1 over sine of pi. And the sine of pi is 0. And then you messed up from there. But if 0 is in the bottom, you can't do that. So we're undefined. Okay, that's sort of part 1. Definitely review. Call that part 1. Let's go Roman numeral 1. Roman numeral 2 would be, what if I force you to think backwards? It's going to be 3 Roman numerals today, by the way. And I say sine of x equals 1/2, cosine of x equals 1/2, and tangent of x equals negative square root 3. So mix it up a little bit. And let's find answers on 0 to 2 pi. So now we're having to think backwards. Some of the values are the same. So those first two are very similar to 1 and 2 from the warm-up, or from the warm-up. The second one is a little different, so be careful. So think through and see if you can work backwards. If the answer is 1/2, what angle or angles, plural, did that happen at? If the cosine is equal to 1/2, what angle or angles would that happen at? Where is the sine equal to 1/2?
Pi over 6 and then 5 over 6.
Good. So pi over 6, and then sine's also positive in the second quadrant, so that would be the over 6 in the second quadrant, 5 pi over 6. Monty, where's the cosine equal to 1/2?
Pi over 3, 5 pi over 3.
Pi over 3 for sure. And then also in the fourth quadrant, so yes, 5 pi over 3. Good. Ian, where's the tangent equal to negative root 3?
2 pi over 3 and 5 pi over 3.
So definitely in the second and fourth. And it's got to be over 3, so over 3 in the second and fourth. So yes, 2 pi over 3 and 5 pi over 3. Okay. All of that's still old news. I think inverses are old news as well, but if I'd say the inverse sign of 1/2, that's only supposed to have one answer, right? Because if you have a calculator and you do inverse sine, your calculator can't give you two answers. And in fact, for something to be a function, it has to only have one answer. And so there's lots of places where the sine is 1/2. In fact, we only gave 2 of them, but we could have got creative and said negative 7 pi over 6 or negative 11 pi over 6. ... There's a lot more. If you remember, though, for picking which one for inverse sine, you pick from the first and fourth. Because you need one quadrant where sine is positive, and you need one quadrant where sine is negative. So the inverse sine of 1/2 is pi over 6, and pi over 6 only. Because you're not allowed to look anywhere else. Only in the first quadrant. Or fourth, but it's not positive in the fourth quadrant. If we want to do inverse cosine of 1/2, so that kind of matches what we just did, but I'm only supposed to have one answer. Which of those answers do you think would be the easiest choice? Which one do you think we went with? What's the simplest answer? Pi over 3. So if you can get your answer from the first quadrant, get it from the first quadrant. If not, get it from the closest spot you can. And for cosines, that means you'll be looking in the first or second quadrant. If we want the inverse tangent of negative root 3, again, we found a couple places where that happens. This would be one that kind of messes people up. So I know it happens at 2 pi over 3 and at 5 pi over 3. Like, which answer should I pick? Well, I'm going to tell you to pick the closest answer. Does anybody remember what this answer is? Because it's not 5 pi over 3, even though it is this angle. What's the quickest, easiest way to get to that angle? Negative pi over 3. All right, let's put them all on one picture here. So if you're doing inverse sine, you're going to be looking in quadrant 1 and 4. Inverse tangent goes there as well. And then almost always paired with sine is cosecant. So if you've got sine, tangent, or cosecant, you're looking in quadrant 1 or 4. Because all of those things are positive, everything's positive in quadrant 1, and those things are negative in quadrant 4. And if you're in quadrant 4, use the negative angle. Like, get there as quick as you can. So the name of the game is pick one answer and pick the easiest answer. So if it's in the first quadrant, go with that. If it's negative and you got to figure out where to go, pick the easiest, closest spot. Right, quadrant 1 and 2, that's for cosine and his friends. So inverse cosine, inverse cotangent, and inverse secant. That's the lesson or reminder in one picture. So let's flip it over and work some of these together here. So arc sine of 1/2. In fact, I think we can pick on people for the first two. Then we'll be a little more careful. Lauren, arc just means the same thing as inverse. So inverse sine of 1/2. pi over 6. Ian, inverse cosine of 1/2? Pi over 3. Okay, now if we get negative, that's where we got to be careful. Inverse sine has to come from 1 or 4. So, well, it's negative, so I won't be in quadrant 1. I'll have to be in quadrant 3 or 4, but we're never in 3. So I need an answer, Brandon, from quadrant 4, an angle whose sine is negative 1/2. So I need the angle in quadrant 4 whose sine is negative 1/2. Good, negative pi over 6. Probably the most common mistake on this whole page is to know you got to be in quadrant 4, know that it's over 6, and so you say 11 pi over 6, but that's not right. You have to get there the quick way. All right, number 4, Mia, inverse cosine of negative 1/2. I'll walk you through a little bit of it. So inverse cosine has to come from 1 or 2, because cosine's positive in 1 and negative in 2. This is negative, so I know I'm in the second quadrant. So what angle in the second quadrant has a cosine of negative 1/2? Good, 2 pi over 3. Okay, let's skip down and find maybe a harder one. Let's do 13 and 14. And 15. So why don't you do 13, 14, and 15, and then we'll compare answers. That one on film here. You don't have to memorize the quadrant. If you always pick the closest, easiest, most sensible answer, you're going to be right. So, Quinn, what angle has let me phrase it the right way. What's the inverse tangent of the square root of 3? Pi over 3. I mean, it also happens at 4 pi over 3, but that's too far away. I don't want to worry about that. Give me the easiest, closest answer. Addie, how about the arctan of negative root 3 over 3? Good. 2 3's make a 6, so it's definitely over 6. Tangent is negative in the second and fourth, but fourth is the easiest to get to. So yes, negative pi over 6. And Kylie, well, similar quadrant. Arctan of negative 1? Negative pi over 4. Okay, let's see. What would be a hard one? Well, you tell me. You look through number 32. What would be a hard one? Anything down there toward the bottom doesn't look so nice. Let me pick one. Let's do 28 and 31. Arcsecant. I don't want to mess with secant. Who's the reciprocal partners with secant? Cosine. So I'd much rather answer the question arc cosine of negative 1/2. So now I turn this into an easier problem. Let's see, cosine's negative in the second and third, but we never use the third. So in the second quadrant, that'd be 2 pi over 3. Arc cotangent. Got to come from 1 or 2. It's positive, so it's definitely going to be 1. Either you have the tangent rule memorized, or maybe you have to switch this to a tangent. 1 over square root of 3, which is the same thing as root 3 over 3, which now I can use the tangent 3 trick. 2 3's make a 6. Solve a tangent problem rather than a cotangent problem. 33 through 36, or 38, excuse me, are just two problems in one. So, I've got 4 popsicle sticks left. So, let's do 33, 34, 35, and 36. And we'll have used all. So 33 through 36, then I'll... So there's the answers to 33 to 36. Your assignment is the rest of them. Not most of you. Some of you have done a big chunk of them already. And then remember that due tomorrow is not this worksheet, but worksheet 1 through 4, which is hopefully already done. So if you're staying caught up, you don't have much homework tonight. You might not have any homework tonight.